Welcome to the Crazy Hat Chemist. So here we are doing another video on bonding. So let's get moving. Bam! Today we're talking about bond hybridization. Okay? So just to think as a little off the side topic here. Hybridization, you're familiar hopefully with hybrid cars. Hybrid cars use a gas engine and an electric battery. So it's a hybrid between gas and electric. So sometimes it's the gas engines that's moving the car, and sometimes it's the battery that's moving the car, and sometimes it's a hybrid that is a combination of both that's moving that car forward. So bond hybridization is very similar to that. So instead of having pure s, p, and d orbitals, we are going to mix these such that we have hybrid orbitals, like an sp hybrid orbital, or an sp2, or an sp3, or an sp3d, or an sp3d2 hybrid orbital. These are generated such that the hybrid orbitals formed are equivalent in bonding atoms. Okay, so here's how we're going to figure out how the hybrid orbitals are and what is the name designation for them. Okay, so the central domain, the counting, and the hybridization, this is really what we're looking for, is this hybrid orbital designation. So if you only have one region, it's an s-type orbital. There's no hybridization because you haven't combined an s with another type of orbital at this moment in time. But when there are two things around the central domain, then you have an sp hybridization. So what you're doing is you're counting from the top all the way down to the bottom until you get to what you want. So in this case, we're doing sp1, we don't write the 1, and it's just sp. So if we have three domains around the central element, it's sp1, p2, which we call sp2, there on the right. If you have four domains, then it's S, P1, P2, P3, and we get sp3 hybrid orbitals. Okay? If there are five domains around the central region, then we have S, P1, P2, P3, D1, and we call that sp3d. We forget about the 1. And then the last potential possibility is with six domains around the central region. This is that octahedral structure. And that's going to be S, P1, P2, P3, D1, D2, and we call that sp3d2 hybridized. So if at most we have 6 regions, so this is the maximum that we can possibly have, we're counting the number of regions or domains around the central element. And it doesn't matter if they are bonding or non-bonding regions around the central element. That's key. It could be either bonding or non-bonding regions. So bonding regions means it's a pair or more than a pair of electrons bonding another atom outside that central element. If it's a lone pair or non-bonding region, it's a lone pair of electrons on that central element, and it's a lone pair of electrons. So again, if there's just one, it's not a hybrid orbital, it's an s, and that's not a hybrid. But if there are 2 regions around the central element, it's sp. If there are 3 regions around the central element, it's sp2. If there are 4 regions around the central element, it's sp3. If there are 5 regions around the central element, it's sp3d. And finally, if there are 6 regions around the central element, it's sp3d2. Okay, so make sure you look at some future videos to see how we are actually going to apply this bond hybridization. And it's just counting up the domains around the central element. Those domains can either be bonding to another element, or non-bonding lone pairs around the central element, not around the outside elements. Okay, I hope you enjoyed that video. It gives you a great introduction, and I feel like George Washington wearing this hat. What do you think? Give me a thumbs up. Subscribe to my YouTube channel, and I'll see you next time for more cool chemistry videos. Bye now.